Yes, this is the this is the sixth session of this ongoing faculty development program, and welcome again in this session. And we are going to discuss about 2D and 3D plotting, which is very helpful and useful for all type of to visualize all type of findings. So before starting, I would like to share my screen, and you can have this my MATLAB screen, and the script file I have prepared very nicely, so that in the minimum time I can explain everything. Okay. To prepare this file, I required about 6 hours, and I will try to present within 1 hour. Okay, so defining the plotting in MATLAB. In MATLAB, plotting refers to the process of creating visual representation of data using graphs or charts. MATLAB provides a variety of functions and tools for creating different type of plots, allowing users to visualize and analyze data in graphical format. Some commonly used plotting functions in the MATLAB include which are listed below. So here we are using like creating data. This is the process how we can do. Okay, so first we need to create the database. So first you need to create the database. This data can generate within MATLAB, or we can load from external sources such as files or database. But in our case, we will generate a database in the MATLAB itself. And if you have database in your Excel, if you are working on image processing or data science, then you have some data in Excel format, you will import. So the rest or the other things are same. Okay, so here selecting the plotting function, there are several type of functions which are inbuilt in MATLAB, and by using all these functions we can visualize our findings, our results, whatever we have. So these are some common functions like a plot, which is used for a 2D line plot. Then we have scatter, which is used for uh, data, okay, for a scatter plot. Then we have bar. This is also used for the uh, database. Histogram is there. So these are some functions which are highly used for 2D plottings. Then after we can customize plot appearance. After creating a basic plot, you can customize its appearance by specifying various properties such as color, line styles, markers are there, axis label, title, etc. So by using all these, we can easily customize. And during the entire session, we will present some few examples which will include all these type of how we can create a vector, how we can create a database, and how we can plot, then how we can customize according our desire. Okay. Then displaying the plot, once the plot is created, customized, you can display it on the screen and using show. Okay, you can use this function. But here we will do directly. And also additionally, you can save the plot to the file in various formats, which is like PNG, we can save JPEG, we can save the file in PDF format also. We have EPS format is there also, EPS. If EPS, so this format is also can be used if you are preparing your document using LaTeX. So all these type of format we can easily import in LaTeX computing. Okay, LaTeX scientific document, scientific documentation. Okay, so all the formats we can reduce. And now come here. This is very simple example. We are using here plot function. This is the syntax for the plot, and this function is used to create the 2D line plot, and it can be used to represent the data point connected by a straight line. See, here you can see usually we are using only CLC clear, but here we are including one more function which is close. You are very familiar to use CLC, clear the command window. You know about the clear to delete or remove the variables which are available in the workspace. But close, when you will plot any graph, the new window will open, and to close all these, we are using close function. Okay, I will you will see at this place now. So here you can see we have x vector. So there are different various type of line spaces we will use, but here we have line space. Okay, we are using line space. This what will do this line space? This will generate the interval is 0 to 2 pi. Okay, this is the starting point. 0 is the starting point, and 2 pi is the last point, terminal point, end point. And these are the number of points. Okay, 100 points will be generated between 0 to 2 pi. So this is one vector, one array. Then all these points will pass through this sine function. You can choose any function, and you can see this is the very simplest example here. To plot this graph, only you need these three statements to plot to the line plot. Okay, for 2D line plot, you need only these three statement. One is x input vector, then we need y function of x, and then use the plot function. Okay, so first we have x, then y. X is independent. X is independent. Okay, y is dependent. So first we need x, then y. If you will interchange, then this will be problem. Okay, so here you can see x is input and y is output. So this vector will pass through this one. So in the same sequence, we will use at this place. When you will execute this section, okay, when you will execute this section, press at this place, and you can see you have very nice graph. Okay, on the horizontal line, you can see 0, 1, 2, 3, up to 7. And on the vertical line, we have -1 to 1 because sine function lies between -1 and 1. Okay, now see, I am going to jump to the second section. Okay, but the thing is that this image, this window is open for the previous section, but in the second section, I am using the same statements, and here is CLC clear and close, and we have x random from 1 to 50, and same we have y. These are also 1 to 50 randomly. So this will generate some data. Okay, so we are creating a scatter plot where individual data points are displayed without connecting lines. Okay, so these are not connecting. We have only scatter points, and we are using here scatter function. So we have two arrays. One is x and other is y. Okay, and at this place we are using scatter function. So these are two arrays on the basis of data. And when you will execute this section by pressing at this place, yes. So you can see this is scatter graph. There is no connectivity between these points. Okay, you can see. So all the points are scattered throughout this plane. And the previous window automatically closed. You can see here is only one window, one figure window, because this the previous window closed because of this function which we use at space close. Okay, CLC will clear the command window. Clear will just 1 minute. Yes, clear will clear the workspace, and close will close the figure windows. Okay, so all the windows will be closed, and only for this section will open. Similarly, you have the next one is also very simple example, and we have x is one vector from 1 to 5, and this is some our database having this element 10, 24, 13, 7, 15, whatever we have, and bar. So this will generate bar plot. Bar is used for bar plot. Okay, this will generate vertical bar plot. See, you can press and we have bar plot. Okay, then come to next histogram is also there. So for the histogram, you will
Sir,
use
plot is not visible. Graph is not visible.
graph not visible.
Yes, sir.
Okay, just 1 minute. If graph is not visible, I have to repeat all these things. Just 1 minute. If graph you are not showing, okay, you must speak in the beginning. Okay, see here when I will execute this statement. Yeah, I share only the MATLAB window. That's why now I share the entire window. Now everything will be visible to all of you. So when you will execute this section, see, yes. So you can see this is the graph. Okay, now it is visible.
Yes, sir.
Yeah.
Yes, sir, it's
Okay. Thank
visible
you.
now.
Yeah. Thank you. So you can see there are only three statements. First is vector by using line space, and we have the interval. Once again, I am going to repeat. We have 0 to 2 pi, and this is the number of points. If you are using it at this place 100 point will be generated. If you will use at this place 50, 50, and again run this file, this section, you can see the graph is in this way. Again, if I reduce this value, I have say it is 10, say it is 10, okay, and run. So you can see this is like in this way. So if you have as much more number of point, the graph will be smooth. Now you can see this is one part of the straight line. Then we have this the another part of straight line. Then we have this is the another part of straight line, and the whole graph is divided into 10 part in line segments. Okay, one is this one, then next, and so on. So for the smoothness, we need more point. So as much you have, you can increase the number of points. Okay, now when you will run again, see the difference. Now this graph is very smooth. Okay, so according to desire, we can increase or decrease this number of points. Similarly, you can see at this place we are generating two arrays randomly. So this is the random function. We are generating this database for the scatter plot. Okay, and this is the scatter function, which is inbuilt function in the MATLAB, and this is the corresponding syntax. This will create a scatter plot, and this is the corresponding database you can generate. Okay, when we will run this section, you can see we have this is the scatter plot. You can see. Okay, now you can see once again I am repeating, this is the image at this place, but when you will run the next session, and you can see I am using close in every statement, in every section. Okay, so when I will execute this section, this will clear the command window, clear all the variables which are exist in the workspace, and close all the image windows, okay, or figure windows. So that's why we are using close also. You can see at the bottom here is figure image is there. When I will execute this sequence of statement, what is there? We are plotting the bar graph. Okay, so first we need to create database. One is X array, and this is our Y array corresponding to H. When X is equal to 1, we have 10. X is equal to 2, we have 24. X is equal to 3, we have 13. When we have X is equal to 4, we have the value of Y is 7. Okay, so in this way, we have these two vectors. And bar is inbuilt function in the MATLAB. Okay, so this will generate a bar graph. See, very simple. Okay, one more thing I want to let you know. In the workspace, what you can see, the length of both the vectors x and y are same. Both are equal. You can use whose. See, x and y both have same size. Okay. Now, when you will select this one and control, these two both are selected. Now come to at this place, and you can see there are various type of icons are there for plots. Okay, there are various type of plots. So whenever you will import database in MATLAB, this will appear like in this way. I will show you in the coming sessions, but I think we are not working on data science. Okay, we are not using any kind of a database. Okay, but I show you how these icons are helpful for you. See, just you need to select these two variables x and y. When you will select this one, we have this graph. When you will choose next, we have multiple graph. Then you can choose area. We have area graph. On the horizontal line, we have x. On the vertical, we have y. When you will select this one bar, the bar plot is there. Okay, so whatever you will choose, scatter. Okay, when you will press scatter, the scatter graph is there. When you will choose pi, okay, you can choose histogram. You can choose semilog. You can choose semilogy, log, error. Okay, you can see this one. And when you will press at this place, you have numerous type of patterns for the graph are there. You can choose according to your choice. But while using, there are some specific use, just like you can see at this place. These are some simple use. Then we have line plots are there. Then we have MATLAB, STEM, and stair plots. Okay, this is the stair plot. You can see this is the stair plot, and then we have MATLAB bar plots. Okay, both are. One is this type, and the other is in this way also. Okay, and if your database is in 3D, if your database in 3D, then you can use these also. Okay, these are 3D plots for database. Histogram is there, and we have Pareto, you can see. So all these graphs have some specific use, depends upon your work, how you want to visualize, why you want to visualize in the specific pattern. Okay, bar plot is there also. This is like a polar plot. Okay, so all these are polar plots are there. Just you need, if you are not familiar, if you are don't aware about the name of the functions, all the icons corresponding to each one is there in MATLAB. Nothing you need to remember. Everything is in MATLAB itself. Okay, compass. Sometimes if you need like in this way, you can use. Then we have MATLAB geographic plots. Depend upon if you are working in some like a geographical study, then you can use this type of graph also there. Okay, so everything is there in MATLAB. Just you need to go through where you can access all these things. Then you can see here is like a MATLAB analytic plot are there. You can choose. Yes. Okay. And then you can see here is map show like this one. If you are working in the signal processing, then these icons which you can see at this place are specifically used for image processing. So all these icons which you can see at this place only for signal processing. If again you can see scroll down, this icon is also used for signal processing toolbox window visualization. These are also for the same. If you are working in the statistics and machine learning, then we have this type of graphs are also there. You can see. Okay, all these are used for, yes. Okay, so this is all about the apps for 2D plotting, line plotting, and different type of use are there. And as soon as we run the command functions in the MATLAB by selecting these two, okay, one more thing, if you are not selecting any vector, then these icons will not work. This will work only for when you will choose something. Okay, so when you will choose one vector, then you will have these icons. If you are choosing two array, you can see here at this place box plot. This is the box plot. Okay, so everything is there in MATLAB. Everything is there. So all these graphs are used for statistics and machine learning toolboxes plot. You can see. Just you need to select one vector, two vector, or three vector, and all the icons will appear at a place. You can visualize according to your desire. Yeah, this is the comet. Comet plot is also there. Okay. So and you can see all type of graphs which we plot, the corresponding command you can see in the command window. Okay, so when you will start to use, you will be very familiar about all type of functions, but depend upon the work. Okay, so all the functions are in MATLAB, and we need not required to remember anything. Just you need to familiar how you can use all these types of apps which are available for the plot, and for the other task you can see, this is all about like curve fitting, optimization, PID tuner, system identification. Many things are there. Okay, now come to our ongoing session. Once again, I am going to just 1 minute. Yes, come in our core file, which is script file. So histogram. Now this is the histogram, and you have to use this function histogram. Don't use hist. We can use hist also because this is available in the old version of MATLAB before, I think, 16, old version. Okay, but we are using right now MATLAB window version 2022. So in this in the function, same function has been updated. We have to use at the place histogram, and you can see we have, this is the random database, and we want to histogram at this place, histograph. Okay, and you can easily execute this section. Just 1 minute, I have the, yes, where is the icon to run the script file editor. Okay, this is the histogram. And in the next session, we are using, this is very interesting for you. You can visualize the image also. You can visualize image. So I have one image in my current directory. This is my current directory, and I have one image. You can see, I think this is the image. Okay. Download. Is there any download? Yeah, this is the image. Okay, this is the download. This is the image. The file name of the image is download.jpeg, and you can also import in the MATLAB, and you can visualize. Just you can see this function will be used, image read. Okay, image read function is used to import this file in MATLAB, and then at the place you will use the extension, the name of the file with extension. So you can see the same name which is at the place for the file we are using at this place. What will do this statement? This statement will import this image in the MATLAB and will be stored in this assignment variable. If you want to show this image, then you will use image show. Image show function is there. This will show the image, and see, I am executing this section by pressing at this place. Yeah, and this is Ramanujan. Okay, when we import this image in the MATLAB, now this is not the simple image, this is the MATLAB image, and the extension of this MATLAB, this image is .m. Okay, and when you will close, I want to show one more thing. See, when we import this image in the MATLAB, okay, and the information about the image has been stored in this assignment variable. Okay, now come to workspace. This is the workspace, and you can see the size of this image. Okay, the value of the image, and you can see this is 148 by 151 by 3. Okay, so if you want to visualize the information in the image after importing in the MATLAB, just you need to click at this place, double click on it. Okay, so here you can see this is the first vector, this is the first vector, and these are only the numbers, okay. So when you will import an image in the MATLAB, this will be only the numbers in 3 layers. So this is the first layer, okay, which is for red, Okay, these numbers are used for red color. And when you will scroll down, when you will do scroll down, when you will do scroll down, okay, 148 by, okay, what I am doing, I can copy this part and come to in the command window, come to in the command window. Copy and paste here. Okay, sorry, not working. Okay, so here is this the first one. Then after, when you will check it by scrolling down, you need to scroll very carefully. You need to scroll down very carefully. And just 1 minute, this will take more steps. 136 to 144. Okay. Yeah, this is the second layer. So second layer starting from this place. Similarly, you will have the third layer and the size of each will be same. Okay, each will be 148 by 151. Okay, and all this image divided into three matrices of the same size. Now after that, the scientists who are working on the image processing, those people deal with these numbers. Okay, we play those people, scientists, play with these numbers. Okay, so whatever we have, when we are sharing any image with anyone through WhatsApp, any social media, we are sharing only these numbers. Numbers are important. Okay, so this is just to show you how we can import the image and how you can visualize. Now come to the next level. Yes. So here is also very simple example uh, to visualize surface in 3D. Okay. See here, we have x, y, two variables are there, and x and y both are from range -2 to 2, -2 to 2, and here is also y -2 to 2. Okay, but here we need mesh grid. What this function will do? This will generate grids of the same size, and only then we are able to plot this function which is in 3D. Okay, and we will visualize at the place by using surf function. Surface is there, so this will generate the surface in 3D. For this above function, whatever you have function of two variable, okay, you can easily generate the surface. And there are various type of functions for 3D plotting. We will discuss all these functions one by one, but right now just I am presenting one example. So when you will execute this section, see at this place, yeah, we have, this is the 3D plot and this is the corresponding surface for the same. Okay, now one more thing which we need to check. Come to workspace. So by using this mesh grid, and you know the length of each x and y are same, -2 to 2. Okay, and we have the x and y both are same size. When x and y will be both same size, only then we can pass these values through z function. If x and y are not same size, then this graph will not plot. So that's why we need mesh grid. Okay, if you want to check these values, see, I want to click on this. Okay, so this is the values of x variable, and you can see x is from the left we have -2, and on the right hand side when you will scroll on the at this place we have is 2. Okay, so -2 to 2, but to make equal size we have this matrix which is 41 by 41. Okay, and all the elements in each row corresponding to column are same. You can see these values are same. Now check the second one. Check the second one. But in this case, the top row is -2, upper value is -2, and lower value you can see is 2. Okay, but the size is also same. uh, you can see this is also the matrix of 41 by 41, 41 by 41. Okay, so by using mesh grid, you can easily generate the same size of x and y, and when both are equal, only then you will have the graph for our desired function. So this is the use of mesh grid. And here is also we have contours. You can generate contour. We are doing here two graphs are there. One is mesh grid. Then we are plotting the contour. Okay. Just you need to run this section, and you can see these are the contours. And also one more thing, you can use at this place surf C. When you will use surf C, this will generate contours as well as surface. Both will be there. Yes, you can see in this graph, we have the surface as well as we have the contours in the same image. Okay. Now, this is just the overview. Now we need some critical study about the plotting. Okay. So here we have is basic line plot. We are creating the data by using the same statement. Here we have is x is equal to line space, and this will generate 100 point from 0 to 10. Okay, everything I have mentioned in every statement, so that whenever you have this script file, you can easily go through, you can understand, you can use anytime in your future. Okay, so whenever you feel that you forget anything, don't worry about that. You need just to access this file. Everything what you need for your use has been clearly explained each statement wise. Okay, so here in previously we are using only these two statements, and after that we were use plot function. But now we include some more functions to include and to customize our plot. We are using at this place title. So if you want to insert or add title, then title function is there, and this is the string. Okay, so string will always be inserted by using single quote on both sides. Similarly, you can insert X label. For X label, we have X axis. You can customize according to your desire. And here is also Y label, Y axis. Then we have grid on. Okay, this will display the grids. Grids are just we have the partition of the entire plane by using horizontal and vertical lines. Okay, when you will execute this section, okay, so pressing at this place, and you can see the entire graph at this place. Okay, so here you can see the grids also. At the bottom we have x-axis. On the left hand side we can see a y-axis, label, y label, and or at the top you can see the title of this image. Okay, so everything we can define in the single sequence of a single file in the pattern of by using the pattern of the sequence of statements, and everything what you need to include in your image, everything is there. After that, we have multiple line in one plot. Sometimes you have two graphs or two functions, three functions, and you want to plot all together in the single image. You can do. See at this place, we are using the x vector line space. Same we have as we use in the previous section. Line space from 0 to 10, and we divide in 100 points. Okay, we have two functions, one is y1 and y2, and how you can plot these two functions in the same image. See, you can extend for the more functions also, but here we introduce only two functions. Then you can use for three functions, four functions. See, this is x y1. X is input, y1 is function, depends upon x. Okay, then we are using at this place the red color. R is used for red color, and hyphen. The here line will be in dot dot. Okay, and x by 2, x by 2. So the first one will be the line, and the second one we are using hyphen two times. So this will be dashed line for cosine function. So this is the second function xy2. X is the input variable, y2 is the second function, and the color will be blue, and line will be dashed. Okay, after that you can use the other functions. A title is there, legend. Okay, because when we have multiple graphs and if we have only the colors, we are not able to recognize which graph is used for function 1 or function 2. So for that we will use legend. Okay, legend will help us to recognize the graph of corresponding function. And same, we have the x label, y label, and grid. Now you can execute this section. Okay, and run. Yeah, now you can see at the place we have two multiple graphs. We have two graphs along with the in the bottom you can see x label, on the left hand side we have y label, or at the top you can see the title, and this the legend. This is the legend. So red color refers to sine function, and the blue color refers to cosine function. Okay, so that's why we need legend, and this will help to study the multiple graphs. Okay, at this place we have two functions. You can have three, four, five, any number of functions. But if you are using legend, this will help you to study the graph critically. Are you getting everything? Is there any question? I think the content which I discussing with you are simple. Just you need to follow the instructions statement, X label, Y label. Many things will be commonly used in all the images, and the things which we are discussing at this place will also be helpful for the 3D plot also. Only the function will change. Okay, and mesh grid is there. Rest all the things are same. Okay, so at this place,
Hello, Prof.
yes, yes.
Yes, the material that you are using, please, how do you get the material?
I don't get your question. Please, can you repeat
I
your
said the
question?
material that you are using to lecture us. How do we get the material so that we have access to
Okay.
it?
Okay, how you can get the material which we are
Yes, what
presenting?
you are using to lecture us, sir.
Okay. We will discuss later. So all
Okay,
the
sir.
participants
Okay.
who are registered at this platform can easily access by logging their account. But there are some participants who are not registered at this platform. Those people are not able to access this content. Okay.
Okay. Okay.
Yeah, this is the main reason.
Okay.
Okay. So
Yes,
once
sir.
again, I'm going to share my entire screen and come to this point. Yes. So at the place we discussed about the colors, and now how you can customize 2D plot in MATLAB. So at this place, what we are doing, we can include markers, color, labels, legends. Also, some we have discussed about the colors, labels, and what are the markers, font size, font format, etc. Everything we can include. Okay, see, yes. So here you can see the same function we have. We are using at this place line space from 0 to 2 pi, dividing 100 point into 100 point. Okay, so this is a very familiar statement. Then we have the function. These are two functions, y1 and y2. So these statements are very familiar. And at this place also you can use close. Okay. Now we have figure. Here at this place we have the plot. This will plot one graph for y1, and what we have included at the place. See, this is xy1. Then this is the style. Okay, we are using marker and line. Okay, then line width, we are customizing at this place line width which we assign at this place. Okay, along with the here is marker. Two things are there. One is line, and by using this one, we are customizing the line width. And this sign like circle, okay, this is the marker. We can customize the size of the marker, and we are doing at space 8. Also, a marker have the edge color. You can customize the marker edge color, which is B. Marker face color, which is red. Okay. And hold on, hold off. When you want to combine two functions, two images in the same, then we can use hold on and hold off. Okay, see, at the place we are using for one plot, because there are some more parameters for the marker, line width, marker size, marker color, edge color, etc. So this statement becomes very large. Okay, so this will generate only one image, but we want to include the graph for this one. For that, if you have more functions, you will use hold on and hold off. The other statement will be between these two statements, hold on and hold off. Okay, so this is the second image graph for the second function. Okay, and the rest we have the marker is different, and you can see at the space line is hyphen and marker is s. And the other parameters we have, some are different, some are like size and marker size are same, but at this place we are using blue color, at this place we are using green, at this place we are using red, at this place we are using yellow. Okay, hold on, hold off. So what will do this one? This will include this graph in the previous one. So these two graphs will be in the single image, single figure. After that, what? We are using grid on, and you can include X label, Y label, and along with the address space, you can see. For the X label, in the previous, we use only X axis, but now you can manage, you can customize font size at the place. Okay, so font size is 30. This is the X label, and this label will print on the image, but you can customize the font size of this text. Okay, then you can, if you need bold, if you want to bold this font, you can make font weight bold. Similarly for the Y label. Okay, and then after we have the title, this is the title of the image, then you can customize the font size for the title, and you can make it bold. So in this way, by using all these, you can easily customize the text which are included in your image. Okay, for corresponding to all the labels, lines, markers, whatever you include, because sometimes we need to customize. If you are using simply, then after the graph is not look like we need or our desire. For that, we have to customize. There are two ways. Either you can define address place, which we are doing, the other way, which I will also explain you later. Then you can need to add legend. Okay, so this is the first function, this is the second function. Now you can make, customize the font size for this legend. At this place we have the same pattern. Okay, also you can customize, you can assign the limit for x-axis and y-axis. You can see this is the x limit, which is 0 to 2 pi. Okay, 0 to 2 pi, and y limit minus 1.5 to 1.5. You can set the tick markers also, GCA. Okay, what will be the tick marker? When I will plot, then I will let you know. Okay, so GCA, font size 15, font name Arial. You can customize all these tick also. Then you can save the file. You can save at this place file. What is print? This is the file name. You can customize according to your choice. Okay, and you can give the extension. You need PNG, then .png. If you need PDF, use at this place PDF. You need JPEG, you must use extension at this place JPEG. Okay, and then all the steps are also has been explained in the same. So all these steps are related to this section which we do at this place. And when you will execute this section, see, this is the image. Okay, so here you can see X label, Y label. These are bold and size is according to your choice. You can customize. Title is also in the bold, and you can see the markers which are used at this place. And green, yellow, yellow is the face color, and the edge color is green in this one. Okay, and the other we have two colors. The face color is red and the edge color is blue. Okay, according to that, these graphs has plotted, and you can see legend on the top right corner. Okay, and axes are there, and also these are the ticks 0, 1, 2, 3, 4, 5, 6, and you can see that these at this place the size of these ticks are larger is the previous one. Also, you can see this range, the x limit and y limit. Y limit we have minus 1.5 to 1.5. Okay, see on the left hand side. See on the left hand side, this is the customized range for x label minus 1.5 to 1.5, and on the right hand at the bottom, you can see this is the range corresponding to 0 to 2 pi. Okay, this is the range from 0 to 2 pi. So in this way, you can customize everything in the image what you need. Here is also one more example. Below is an example code snippet that demonstrate how to customize 2D. Okay, I think this is also similar type example. Yes, this is a similar type of example, but see what happen. What is the difference? We have to execute. Yes. So here you can see on the X level, you see on the X level, this is the important. Sometimes you need to customize these ticks, which you can see 0, 1.5708, then we have 3.1416, then 4.7124, then 6.2832. And on the vertical line, these are also customized 0, -1, minus 0.5, then 0, then 0.5 and 1. Okay, so how you can do? How you can do? This is due to come at this place. Yeah, these are the customized tick. These are the customized tick. See, on the horizontal line, we have 0 to, on the horizontal line, we have 0 to 2 pi. This is 0 to 2 pi, but this interval is divided with the width pi by 2. Okay, so when you will use at this place, this is the dx. This is the dx, width between 2 points. Okay, pi by 2. So when you will choose 0 plus pi by 2, pi by 2, and pi by 2, and pi by 2, you will have 4 points. You will have 4 points by using this one. And at this place, we have -1 to 1, -1 to 1, but the step size is 0.5. At this place, the step size is pi by 2. So due to these two statement, we have these ticks at this place, which you can see in this image. Okay, so by using these two statements, you can customize all these. The other statements and the functions which we use at the place are similar. And one more thing we can see at the place, grid on and grid minor. Okay, so here you can see there are two types of grids. You can see in this image there are two types of grid. Once I need to maximize the image. Okay, so you can see this is the one vertical line, then we have the second vertical line, and 8 the ticks which we customize. Okay, at the 0, then 1.5708. Okay, and then we have the horizontal lines are also there. So there are two types of grid. One is grid according to tick, and other is small grid which lies between each box. Okay, inside this part we have small grids are also there. So in this image you can see very easily two types of grids are there. Okay, so in this way you can manipulate this part also. Now come to here. We have different type of line space. How to customize plotting using user defined function. Okay, you can plot the user defined function as we discussed yesterday, different type of functions. Okay, in the previous example we discussed only inbuilt functions, but now if you have write your own function, okay, whether it is a user defined, whether it is a uh, anonymous function, you can use and see at the place in the same script file. Okay, here we are using the same line space function. Then we have y is equal to my function. This is user defined function and I am call at this place. I'm calling at this place. See this one. So this is my function and function of one variable, which is y is equal to x square. Okay, I am calling the function in this file at this place. Then I will use rest all the statement which you can see are the same. Only one thing which change is that function. We are not using inbuilt function. We are using user defined function. But if all the files which you create must be in the same directory, this will be easy to plot. You can see this function, user defined function, is in the same place. Here is this is the my function. Okay, and when we will execute, rest other things are same. You can set GCA, set the font size of axis label and title. You can see font name, you can see line width. Okay, so at this place we change the customize the plot appearance, and all the sequence of statement has been clearly explained at this place, and all the things we already discussed. Yes, you can now execute and you can see the graph. Okay, you can see the graph. This is 2D and we use at this place user defined function. And now again you can come to the next example. This is related to anonymous function. Okay, we are using anonymous function and also we are customizing. And see, the pattern is very simple. F is equal to, we have this function at the rate x sin x in one line statement function. Then this is the line space. Then we are plotting at this place. This is the pattern. Only these three statements are important. Only these three statements. So if you are defining the use anonymous function in this way, you have the same x input, then at this place, this is the x input and this is the function, and we want to pass this argument. Okay, so you will use f x. F is function of x. Okay, and the rest the other arguments you can see for the x label, y label, title, grid, etc. All these will remain same, and when you will execute, you can run the file, you have the graph. Okay, you can customize this graph according to your desire, but the only thing which are different, only these three statements. Just see only this syntax. We need to pass this argument through this function. Okay, and the other statement will remain same. you can do according your choice. Any question related to the above discussion, if you have? I think all the text content which we discuss right now are very clear and very simple to use and hands on. The file will be available for you. Just you need to run the all the sections and you will get everything easily. Still, if you have any question, you can ask. Otherwise, we will go ahead. Any question, please?
Sir, what is the meaning of GCA?
GCA. Okay, meaning of GCA. GCA is one type of function in the MATLAB to customize the fonts and see. Okay, so we are using GCA. We are setting the GCA by using GCA function. What we are doing, we are customize the font size. By using the same function, we are setting the font name Arial. Okay, we are using Arial. And by using the same function, what we are doing, we are customizing the line width. Okay, so GCA is inbuilt function in the MATLAB which help us to customize the appearance of the image. Okay, so all the things you can easily customize, mainly text. Okay, see here. Here also we are using GCA. See, at this place, what we are doing? We are setting GCA font size, where set font size and font format for tick labels. For tick labels, which one? Tick label means when you plot the graph, there is horizontal line and there is vertical line. Okay, so all the things directly are not we can manage, but for that we have to use GCA. If you want to check GCA meaning, full meaning of this function, you can go to address place and enter. And when you will enter, you will have the more information about GCA. Yes, okay. GCA here you can find more detail about the GCA. Current axis or chart. This MATLAB function returns the current axis stand alone visualized in the current figure. Graphic. Okay, when you will click on it, and here you will find the use of yes. Yes, so you can use GCA function to customize the other way. AX is equal to GCA. This is the one more example to use GCA function. Okay, so here AX is equal to GCA. AX dot font size. We can customize the font size in this way also. You can customize tick dir out. You can use X dot tick length. Okay, here is the tick length, and you can also customize the AXY limit -2 to 2. This is the another way to use the GCA function. So GCA is an inbuilt function in the MATLAB to customize line width, text, all type of the label, their font size, whatever you want to change. Everything you can customize by using GCA, but you have to define what is GCA in this way. Only then you can use, and these are the examples to use the GCA function. Okay, you can find some more examples by using the GCA. Sorry, this GCF. You got it?
Yes, sir. I think GCA, get current axis. Is it the full form?
Full form. Yeah, this is the full form.
Get
Okay.
current axis.
Yeah. But the main purpose is inbuilt function in the MATLAB to customize. Uh, okay. So all type of functions are there. You can see here, all these are also very, because MATLAB itself is very vast. So, okay. Now come to this part has been discussed. This is also discussed. Subplots. Yeah, this is important. See, here we have 4 functions, and we want to visualize these 4 graphs in different part. Okay, so by using subplot, we can generate matrix of image or matrix images. Okay, how? This is the x and y1, y2, y3, y4, and at this place we are using subplot. Okay, so we divide the portion or the image in the matrix. How? If you are using subplot 2 2, so there
Sir,
will be
screen is not shared.
okay.
MATLAB.
Screen, just 1 minute. I forget to share the screen. Uh, Now it is visible. Yes. So here we have these four functions. You can see y1, y2, y3, y4. In the case of earlier, we plot two functions in the same image, but here we want to visualize all these four functions in the graph in the same image, but separately. Okay. For first function, we have one image. For the second function, we have the second image, but in the single figure. So what we do, we will divide the portion of the image in the form of matrix. You can choose any order. Okay. So this will possible by using subplot. So what is there? We are using subplot function 2 2. So you can see in all the functions we are using 2 2 2 2 first two parameters. This will generate the image of 2 by 2 order. Okay, and this is the first image. You can check this statement very carefully. So these two parameters are same. This will represent the image 1. This is image 2. This is image 3 and this is image 4. Okay, we have four subplots and the sequence will be this is the top left by using this statement. This is the plot function. This is the title for the first image. Then second plot subplot will be top right. This is the top left. This is the top right. Okay, and the function 2 title. Similarly, we have a third image. This will be the bottom left position. I mentioned here very clearly. And the title for the same we have is plot 3. Then by using this subplot, we have bottom right position. Bottom right position. Okay. And we are using at this place plot 4. And when you will execute this section, see, we have four images in the same set of images. So this is the plot 1, image 1, then we have image 2, image 3, image 4. So this is the matrix of the images. Okay, so when you want to plot matrix plot, then you will use a subplot. And also in this image of sets, you can include other parameters like x label, y label, z label, and grid. You can use grid function. So all the entire functions which you use at this place are type of x label, y label, and even you can use a title. Okay, you can use all these parameters. I want to show for one image. You can check it. I'm using for the first one. Okay. I just copy and paste and see again. Okay. So you can see in the very first example, X label is there, Y label is there, and title is there. Okay. Grid are also there. Okay. So all these subplot you can customize again what you need according your desire. Okay, so this is the use of subplot. If you are we have four images. Okay, if you are using 4 1, if you are using 4 and at a place 1, then you have to change all these values. Copy, paste, and again paste, and again paste at this place. Okay, then you need to run. You can see all the are in one column image. Okay, sometimes you have studied this type of graphs in the research papers, and these are generated in this way. Okay, so I doing Control Z, Control Z, and Control Z. Okay, so in this way you can easily customize all these graphs, subgraphs you can use. And here are some types of line space in MATLAB. Okay, so we are familiar about this one. All the in the above examples we use line space, and this is the start, and this is the end point, and this will generate the number of point. Okay, and if you want to display, you can do and run the same, and you can check in the command window. You can check in the command window. You can see. Similarly, we have the another way, colon operator. You can use colon operator in the place of line space. Okay, so here at space we are using the number of point, but at space we are using the step size. Okay, this is the step size. You can use this one also. And also here is one more example to use the log space. Okay, generate the logarithmically space vector or matrix. So this is the x vector. Why we are using this log space? Anyone can explain? Why we need the log space? Anyone please?
Sir, to generate more points.
Why we are using this log space? So all this we have the interval is 0 to 2. We have the interval is 0 to 2. Okay, and 100 points are generated. This is the last value. This is the last value. We have the size is 1 to 100. So by using this log space, we have these parts, and this is the last value. Okay, so this type of vector will be generated. My question is, did you use this log space for your work if it is required? But I did not use anywhere in my work. That's why I am asking from you if you know the use of log space. But we can generate by using this function. This is the starting point. This is the end point, 0 to 2, and n is the number, and you will use log space function, and this will generate these values. These values will be generated by using log space. Okay, and then after we have step function. This also we can use, and you can see the difference is that at this place we are using step size. Okay, as we do in the case of colon operator. Colon operator and step function both are same. There is no difference. Interval is 0 to 10. Okay, and here we have only step size, which is 0.1. And when you will execute, you can check these values by running the file, run this section. Okay, yes, you can see. Just 1 minute. I want to display these values. CLC clear and CLC clear. Yes. And run the section. Okay, this is the step size. And all the values are 0, 101 by 1. Why? Just 1 minute, please. This is the section, step function, start, generate a vector with equal space step, 0.1, 0.1, and 10. Okay, so this will generate only the vector with equal step, with the equal space step. But the thing is, why all these values are 0? Sorry about this one. I am not exactly know the answer why all the values are 0, because I study this vector today, this function. But I will try to find the exact answer, and only then I will let you know. Okay, but right now, sorry, I don't know about this vector, exactly what is the meaning of a step function. Now we have the mesh grid, and we discussed about the mesh grid is used for the 3D plotting. And when you will execute, you can use at this place CLC and clear. Now you can execute, and you can find this is the X and this is the Y. Okay, X and Y both have the same size. So that's why we have the mesh grid, and this is highly used for 3D plotting. Now you can, if you have any function, just like you can choose Z is equal to we have is X square plus Y square. Okay, X square plus Y square, and divide it by, you can divide it by X plus Y. X plus Y. Suppose you have this one type of function, and then surface, you can use surface function, and then you need to pass this argument. These argument are in the uppercase X comma Y. Now it is fine. X comma Y comma Z. And now execute this sequence of statement. Run the section. Okay, just 1 minute, please. Yes, and colon close. Okay, now you can execute this section. Yes, this is the 3D. This is the 3D plot, and after plotting, just 1 minute. I want to replace this part. Just 1 minute, please. 1 minute, please. And here is the image. Okay. Yes. So this is the full image. Okay. And here on the top, you can see there are some small icons. You can see when you will move your cursor on the right corner, you can see here are some corners. When you will use this rotate 3D, click on it and move your cursor on the image, then left click, and you can rotate this image in any direction 360 degree. Okay, this will rotate on the 360 degree. You can move in any direction. So according to your desired visualization, you can fix its position, and then you can plot the image. Okay, so this is the one function, and other is plus sign. You can see zoom in, zoom out. Okay, you can use all these also. And one more thing, you can use at this place grid on, and box on, box on. These two functions also can be used. Other, we have the title, X label, Y label, Z label. You can include all these things. And when you will again execute this section, see now the difference. Okay, now we have box is there, grid are also there. Okay, now you will have various type of 2D and 3D functions. I am not able to present all these during this section, but when you will come at a place, enter at a place only 2D plotting, 2D plot. You can enter at a place 2D plot. Okay, and you will find all the functions in the MATLAB itself. Just you need to click here, and you will find all the entire syntax with the examples you can find here. Okay, these are the syntax. Scroll down, scroll down. All the examples are available in the MATLAB corresponding to syntax. Here syntax are there. Just you need to copy, and you can use it directly in MATLAB, copy and paste. Then you can modify, customize according to your choice. Just understand all these syntax. Okay, various examples are there to use. You can see here are also the example to use the you plot the three functions in the same graph. Then color marker are also used at this place. Scroll down. you can have various type of examples are there to use 2D functions. You can get here many examples are there. Scroll down, scroll down. Okay. And also when you will come to address place all type of line style, which styles you can use are available in the MATLAB itself. Okay. Markers, which marker you can use. Okay. These are the syntax, then description, and resulting marker will appear on the last column. So all the markers which you can use during the image are there. Then you can see the colors. Okay, there are all type of colors which are available in the MATLAB and you can customize for the coloring. So with the name, the complete detail is available in the MATLAB. Okay, and so this is all about. These are also can be used. This also can be used. 100 010. Okay, and these are some more colors you can find. Some more markers are there. Just more colors are there. Just you need to understand these values. These numbers for the color also can be used. Okay, so various type of colors and styles, markers, all the things for 2D are available in this file. Now come to back for 3D plotting. Or 3D, yes, just you need to click at this place. Yeah, we need 3D plotting. Okay, for 3D plotting, you need to scroll down and you can come to surface. All these are line plot, contour plots are there. These are the surface. Okay, you can click at this place, and when you will go to surface and mesh plot, here are various type of functions. All these functions are used for 3D plotting. Okay. And when you need to check the corresponding example and the syntax, how you can use, just you need to click one on this statement, on this function surf f. When you will click on it, you will find the syntax to use in the MATLAB. Okay, these are the examples of the syntax. Then you need to scroll down. When you will go to down, yeah, here are the some examples are given how you can use this function and all these things we discuss in our session. You can include all these examples. Okay, this is the mesh grid plot. This is the surface, and then you can see here is the surface along with the color bar. Okay, on the right hand side of this image you can see the color bar. This is sometimes to visualize our result and to study critical study of the image, we need color bar also. This is required sometimes in our study. Okay, so here you can see various type of examples are there for 3D plotting. Just you need to go this MATLAB content. All the examples are there. Bake, and you can see at this place surf C. Just you need to click and you will have the corresponding syntax. Just you need to understand the syntax. Yeah, here is the same function is there, but we are using surf C. This will generate surface as well as contours, and corresponding to this function, you can see in this image we have the surface as well as the contours in the XY plane. You can see, you can observe everything. Similarly, we have this is one of the more example, and you can go there. Various type of example for corresponding to every function which is available in the MATLAB. Various examples are there to use. Okay, usually I use only surface and surface C, and sometimes we can use mesh. Okay, this is the mesh plot, and when you will scroll down, we are changing only mesh. Okay, and you can see the mesh plot. The inner part will be empty. We have only mesh just like net. Okay, and various examples are there. You can check it, and also you can check the some more examples related to surface normals. Okay, The meaning of this one is surface normal. And when you will check the examples to use, and you can see that, yeah, we have this function and we have the surface as well as normals are there. Various examples are there. Okay, just you need to go through and check all these type of functions. So all these functions are not required, but we need only surface, surface C, or sometimes mesh. These are highly used. But if you have some more required, all the examples which you need in your future for your study, you can easily access all type of examples for your purpose. So now this is all about today's session, and I take more time from your side. If still you have any question, please feel free to ask from me. I thought I will finish today's session within 1 hour, but it is about 2 hours. Over to you. Now it is time for your